Hello everyone. Today's comprehensive lesson is all about getting much more familiar with the use of bar graphs. In various industrial automation processes, specifically when we are connecting an HMI directly to a PLC and monitoring a process, where, for example, we measure temperatures or we measure weight, or maybe we want to measure pressure. If we want to display the values of each of these on the HMI as a graph, we can use a bar graph. So if I come here and click on the part labeled bar graph and go to the main page and click on the X software in the builder, here a new window opens up right here in front of us. And as you can clearly see, a detailed graphical representation is being displayed for our review in this area. Now, we want to take a moment to get much more familiar with how this works, and we can also substantially increase the overall dimensions of the display by using this specific section over here. We can increase the size of the graph ourselves. If I click here, a window will open for us. The first tab it has is Basic. In this specific section of the interface, we can carefully enter the exact street address we're interested in exploring, or alternatively, we can input the specific memory location that we actually want to use as the primary basis for drawing the detailed graph. It is very important that we accurately enter that specific address into this designated section to ensure the system processes the data correctly. If I click here, a window will open for us. Alright, at this point in the process, I am going to go ahead and select the specific controller unit that we have already configured and set up previously. Now, moving forward, we are going to establish a connection between this HMI and an XEP PLC by utilizing a dedicated communication link to ensure everything is synchronized correctly. So I select this controller here, and here we can actually choose the memory. I'll select MW, and here as well we can enter the address that we have in mind. For example, I enter MW100 here and confirm it. So this MW100 is actually the specific memory address location of that memory where we want to visualize and represent the values contained within this specific buffer as a comprehensive graphical chart here. Okay, another setting we can adjust here is the maximum and minimum boundary limits represented on this graph, which we can manually adjust and configure right here, however we like. The first method, which is set to default, is the constant mode, meaning it's a fixed value. By default, the lower limit is set to 0 and the upper limit is set to 100, but we can change these as well. So this means that by default, our graph changes between 0 and 100. Another thing we can do here is that we can set the upper and lower limits through a memory word. We can change its value ourselves. For example, imagine you've connected this HMI to a PLC, and in the PLC, you want to change the upper and lower limits, for instance. Or, for example, we could add two numeric inputs in the HMI, and depending on the situation and depending on the various technical processes that might occur in the system, we can set the specific upper and lower limits ourselves manually. If I configure these specific settings directly on the device, we can manually assign one unique starting address for the lower limit here, and then a completely separate address for the upper limit. Now, if I click right here, a new configuration window will immediately open up for us to use. So this is related to the lower limit, and I can define an MW here. For example, set the lower limit as MW0. I assign the address to it, and for the upper limit, if I click here, we can also assign another address. For example, I set MW1 as the upper limit. So if this is set on the device section, the lower and upper limits of this graph are controlled by MW0 and MW1. We can set their values, but if it's set to the constant section, it's a fixed value. By default, it's set to 0 and 100, and it treats it as a constant value for us. We'll test both modes together in a moment. If I click here on the display section, another window will open for us. Now, we can also change the color of this graph. If I click on this section, for example, select this, and click OK, as you observe the interface, you can see that the specific color and shading of the graph itself can be modified to suit our preferences, and we even have the advanced capability to change the entire orientation of the graph layout. This means we can adjust the flow of data, making it move seamlessly from the left side to the right side, or alternatively, we can reverse the entire view so that it displays from the right side back to the left side, depending on what we need to see. Or you could choose that one over there, or have it positioned from the top as a specific example of how it looks. Or have it set to the bottom position, which was the default setting. So we can actually adjust a wide variety of different settings related to this specific graph itself. We can easily do that right here within the display section of the menu. And we can also manually adjust these individual divisions that you see right here on the screen. We can increase or decrease their values. For example, in the default mode, the scale you see here is set to 5 divisions. That means this graph is displaying values from 0 to 100 for us. And it's divided into 5 sections. So the value of each of these divisions is 20. So it goes 20, 40, 60, 80, and this one is 100. Now we can easily incorporate a clear and descriptive text label right here. This simple addition will make our entire project look much more professional, significantly more precise, and it will truly help us to identify and understand all of the specific values at a single glance. We can do that right here in this section. If I click on this text and then click here as well, we can add a text label here, and we can even change its font, size, and color right here. We usually set the fonts to Tahola. I'll set this one to Tahoma, and for example, we can set the size to 18. Let's keep the color white, and here I'll set its value to 0, so this part corresponds to 0. We can also adjust it precisely right here. Now, if I click on this and make a copy, we can use the same thing for the next sections as well. We can align these two together in a straight line. For aesthetics, I'll click on this. I'll go ahead and set its value to exactly 20. And then once that is done, I'll copy this specific element and paste it right over here. We can also adjust this so that all of them are aligned in a straight line. Here, we'll set this one to 40. Again, I'll paste it the same way. Yes. For this particular setting, we'll go ahead and set this one all the way up to 60. We'll set this value to 80. Now we can carefully adjust these settings once again, and finally, let's look at this last one. We'll set it to 100. So, as we previously discussed, this device can clearly display this range for us all the way from 0 to 100. All right then. Let's go ahead and test the very first mode together, which is known as the constant mode, essentially meaning it stays steady from 0 to 100. We just need an MW100, and if you give it a value, our graph will change. Now, we can read this MW100 value from the PLC and use it in that process. When the MW100 value changes, this graph also changes for us on the HMI. All right, since we want to test this together here, that's why I'm going to do it myself. I'm going to use a numeric input, and here I'll place a numeric input. I'll set its address to MW100, and if I click here, I'll enter the number 100. I'll click OK. All right, we can also, now let's set its text to whatever we want. And let's position it right in the center and carefully modify its overall dimensions just a little bit. So now, if I go ahead and change the current view over to simulation mode, so if I enter a value here, this graph will change for us. For example, I'll set its value, 20. You can see that it changed. For example, I'll set its value, 60. For example, I'll set it to 75. And just like that, our graph can change between 0 and 100. If I set its value to 100, you see? So this can go between, we have set it between 0 and 100 for us. All right, now that we have done that, we can go ahead and make some other minor adjustments to it as well. We can make these settings even more precise now. If you want these settings to be even more precise, that's possible too. If I go ahead and close this window now, and then click directly on this specific section over here, we can actually use this detailed scale to make all of our settings much more precise than before. For example, if I manually set this value to exactly 20, well, you will notice that our scale immediately becomes significantly more precise for our needs. And since it's between 0 and 100, it's divided by 20, which means each of these lines represents 5 for us. So we need to make some changes here. Now, let's do that here based on what we've just set up. Let's update these numbers accordingly. Let's change them. So each of these stands for 5. So this is 5, 10, 15, 20, and here it's 25. So I'm going to change this to music. I wonder if we are going to see the exact same thing happening right here as well. In this first spot, it's 50. Then over here, it's 75. And finally, in this last spot, it's 100. Now, we can go ahead and perform this test together one more time to be sure. If I set this value to 25, you can see it lands exactly here. If, for example, I set the value to 30, you can see that it goes up one line. As we said, each of these lines represents 5. And here, since it's 30, it lands exactly here. If I set it to 80, you can see that it's showing us precisely again. If I set it to, say, 100, you can see that the graph fills up all the way to the end for us. So this graph can change for us between 0 and 100. Another scenario we want to test together is the one where we set the upper and lower limits. Based on these MWs that we've set here, our chart will change accordingly. If I set this to OK mode, then here we need 2 more numeric inputs so that we can manually enter the upper and lower limits ourselves right here. Okay, so I click on this, copy it, and paste it here. All right, I'll set the value for this one. I'll set its value to MW1. This one will be for our upper limit, and I'll copy this one and paste it here, and set this one for the lower limit. If I click here, we'll set this one to MW0, which will be for our lower limit. Now here, again, we can also add 2 text labels ourselves, so we know which one is for the upper limit and which one is for the lower limit. If I go ahead and click right over here, we can highlight and select all of the text in this area. And then once again, we can start typing in whatever we want. Upper. We'll set the font to Tahoma and the size as well. For example, we'll set it to 14, and now we can make it even bigger, like set it to 18. That's good. And we can copy this as well and paste it here. Additionally, we can also choose to set this specific value for the lower limit of the range. Now, if I go ahead and click right here on this interactive simulation window, now we can set the upper limit, for example, to 80. So it'll be between 0 and 80. Now let's see what happens. If I enter here, 50. Well, now our scales are obviously messed up because before we had scaled it for between 0 and 100. But now that we've set the upper limit to 80, our scaling here is messed up too. So if, for example, I set this to 80, you'll see that the whole thing now reaches the end here. If I set this to 0, it becomes 0 here. So as I mentioned before, we need to change this scaling. If we manually configure all of these specific values, we can just go ahead and delete these items right away. In those particular instances where we find that we manually enter the upper and lower limits, because it's constantly changing. So we can just remove these, and we can also set the scaling back, set it to the default state. If I reset it to default and go back to simulation again, then we can, for example, set the upper limit here to 50. If I set this to, say, 40, you can see it only goes up to this part. And if I set it to 50, which is my upper limit, you can see that now our entire graph is filled. So we can change the upper and lower limits using these two values. Thank you for your attention.